On the vast stage of the cosmos, humanity has embarked on a journey of discovery that challenges the limits of our imagination. For centuries, we have looked up at the starry sky and asked ourselves, are we alone in the universe? The answer to this fundamental question has captivated the minds of scientists and dreamers alike. Today we will venture into uncharted territory, beyond the ends of the earth, in search of answers that could transform our understanding of the cosmos. Although we still lack extraordinary evidence of the existence of life in other corners of the universe, we are certain of the essential elements that give life and the environments conducive to its creation. We are still reconstructing our origins. We find fossils around the world of at least 1% of all the species that have ever existed. And that is only on our planet. In space, we have it even more difficult, and we are just beginning to explore with our probes and telescopes. If extinction is the rule, and survival the exception, we must assume that the majority of living beings in the universe that have existed will be dead. Most of the universe remains completely unknown to us. Great mysteries await us about our origins and life. Are we among the first generation of intelligent civilizations, or are we the last to reach the cosmos? Although we cannot answer these questions directly, we can eliminate most of the doubts and find the places where and when they may have arisen. Life is made up of self-organized molecular structures that can exchange energy and matter with the environment, adapt, maintain, and reproduce. Reproduction involves making copies of itself as faithful as possible, thanks to the information contained in the DNA of every living being. The famous physicist Edwin Schrödinger was the first to define what life was from a physical point of view, and the transmission of information is of utmost importance to be able to carry out our actions. In some ways, we are biomachines. The copies are never exactly the same, and this implies that life is subject to natural selection, so that the living beings with the most beneficial traits that best adapt to the environment are the ones that survive and transmit that information to future generations. Over millions of years, it can give rise to a new species. It is the wonder of evolution. Life has a complex chemical composition and is very different from other non-biological objects. On our planet, life needs 6 chemical elements: carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. These elements constitute the mass of any living being, but these elements have not always existed in our universe. Our life is based on carbon, which is capable of creating large and complex molecules. Other alternative biochemistries to carbon have been suggested, such as silicon, which would give rise to a crystalline morphology. But still, we need the rest of the elements to create such complex structures. In addition to this complexity, life needs a quiet area so that it can develop. A galaxy in the habitable zone and a planet with an atmosphere. Liquid water or a similar solvent. Water is something extraordinary. Molecules can dissolve in water and form complex molecules, and to achieve this, you need to be in the quiet zone of a star system, preferably in the Goldilocks zone. It is like creating a cooking recipe. Let's go with the main ingredients. The chemical elements. At the beginning of the 20th century, humanity did not know if the universe had always existed. Albert Einstein even believed that it was eternal and would have no end. Thanks to numerous studies and scientific evidence, we know that the universe had a beginning 13.7 billion years ago and will have an end. Like life, it is also subject to evolution over time. For the first few 100,000 years, the temperature was so high that atoms could not exist. There were loose protons, neutrons, and electrons, a kind of plasma that did not allow light to travel. It was not until 380,000 years after the Big Bang the universe began to cool enough for the first atoms to form. At first they were simple atoms. We only had hydrogen and to a lesser extent helium. The universe had been opaque until then, so now the first light of the visible universe in the form of microwaves was turned on. We had to wait a long time for the first stars with population 3 to form. 150 million years after the Big Bang, gigantic stellar factories were formed. Those stars lacked heavy elements, so they could not have rocky planets and life was not yet possible. Only gas giants could form. This planet called Methuselah, located in the globular cluster M4, is estimated to be 12,425 million years old. These stars began a nuclear fusion process inside themselves to create heavier elements. We know that to create heavier elements you have to add neutrons to an atomic nucleus, and that can only be achieved with highly energetic processes. In their supernova explosions, even more elements such as calcium, carbon, silicon, oxygen, and others were created. Some of those first stars in the universe were too massive to explode in supernovae and collapsed into black holes, in a process known as photodecay. Through relativistic jets, they also expelled the first metals into the universe. The cosmic machinery of creation was in motion, weaving threads of matter and energy into a cosmic narrative that we are still discovering. 300 million years after the Big Bang, primitive galaxies were already forming. At 500 million years, a new generation of population 2 stars was formed, thanks to the metals produced by the first stars. These stellar factories, like divine alchemists, forged more complex elements, weaving the chemical history of the universe as they produced hydrogen, helium, and lithium and beryllium traces. They were very massive and hot, and played a fundamental role in the formation of heavier elements through stellar nucleosynthesis and supernova explosions. There were already enough elements to form rocky planets, but not enough to form something as complex as life. This generation of stars and their supernova explosions, neutron star mergers, and other energetic processes provided the interstellar medium with more essential elements to complete the periodic table, such as iron, potassium, gold, and silver, among others. It is believed that 10 billion years ago, the first so-called population 1 stars began to form, with an abundance of heavy elements and planets capable of supporting life as we know it. The Milky Way was formed from the inside out, with the formation of its central core and its protogalactic disk as initial steps in that process. It is not surprising that almost all ancient metal-poor stars are found near the galactic nucleus, and the youngest like the Sun at its extremes. With what I just told you, we already have a lot of data to know how the first civilizations could have been formed. We do not have a precise answer, but we do have limits for the development of planets with life, and this was 10 billion years ago. 3.7 billion years after the birth of the universe, life on our planet appeared 4 billion years ago. About 500 million years after the Earth formed, but it took 4.5 billion years to develop intelligent life. If we are an intermediate case, we can estimate that the first rocky planets formed 10 billion years ago. Evolution would have created intelligent beings about 5.5 billion years ago. This is not surprising and at the same time worries us. If the first civilizations formed 5.5 billion years before ours, they must be tremendously advanced, or at least must have existed at some point in the history of our galaxy. Where are they? Have we arrived late to the great cosmic stage? If someone came here 5.5 billion years ago, the Sun and the Earth did not exist, it is practically impossible for them to have survived to this day. And if they did, they must have become something else. Everything is subject to change. In our galaxy there is an area that is considered habitable, where it is far from highly radioactive regions, such as the galactic center, or near massive stars, even black holes or pulsars, to quieter regions far from star formation zones. Life can even appear outside this area, but we must consider the preferred one for this study. In this galactic zone, most of the stars rich in metals are found, and also most of the civilizations that must have once existed. It is not strange that we do not find any. Well, like the Earth, we only find 1% of fossil remains in all the species that have existed. In the much larger galaxy, something very similar must happen. Most structures, technology, or ruins of vanished civilizations must be concentrated in specific planetary systems, and in several billion years, any trace of life from their activities will have merged with other elements. Our Voyager ships that navigate through interstellar space, their primordial structure can last about 100 million years before they are completely eroded by micrometeorites and other effects of the space environment. Most scientists believe that anywhere from a few dozen to hundreds of living civilizations currently exist. We are already detecting habitable planets and signs of life in the galactic habitable zone. K2-18b is a possibly oceanic planet located 124 light-years away, about 2.6 times larger than Earth, orbiting a red dwarf. which gives it temperatures between -8 and 5 degrees Celsius. Preliminary analyses by the James Webb Telescope indicate that its atmosphere is hydrogen, and methane and carbon dioxide have also been captured, elements associated with organic life and with indications of dimethyl sulfide. On land, this compound is emitted by phytoplankton in marine environments. More observations are required to confirm that they are indeed due to biosignatures. Kepler 442b is the only planet more habitable than ours. It could be a second Earth, or perhaps a paradise. In our galaxy there could be at least 300 billion planets, one for each star, and 30 trillion exomoons, which is about 100 times the number of planets. Imagine the possibilities of life in the galactic panorama. One thing is certain, Earth was not the first opportunity for our universe to create life. And what I'm going to tell you is even more incredible. We have only taken into account the types of life that we know, but not the types of life that we can imagine and not imagine. The elements of life are present in all places in the universe. Water, oxygen, carbon, and other elements are the essential ingredients found in much of the galaxy, especially in areas of population 1 stars. We have studied our scenario, our galaxy, but what about the rest of the universe? I am sure that there will be a large number of extinct civilizations out there, and that only a few will have survived. There are at least 10 sextillion stars in the universe, more than all the grains of sand on all the beaches on Earth. If a tiny fraction of them had a planet with life, we would be talking about millions of civilizations. Our universe can last about 100 trillion years. From that perspective, yes, we can be one of the first civilizations. We might be the first chapter in a long history of life in the universe, but as far as the oldest civilizations go, it represents the greatest of mysteries. The answer lies somewhere in time and space. We know that once consciousness arises, we develop the ability to destroy ourselves and still do not ensure our own survival. That gives us an idea of what may be happening. Life can expand into countless worlds, only to then become extinct. The ashes of precursor civilizations, like shooting stars in the sky, remind us that time is relentless, but the spark of life and intelligence can be ignited again and again in the far reaches of the galaxy. Our descendants will surely explore the galaxy and find remains of cemeteries from other civilizations. What strange monuments of enormous value will we find on the planets? What probes will we find in the depths of space? New transmitters of civilizations that once looked toward the stars with hope and wonder. If there is someone who has survived, it means that we too can have a future. That possibility full of promise and wonder, it is the flame that guides our journey, a beacon that shines in the cosmic night. Hush.